Okay, so today we're gonna basically look at how to solve the set of equations that we had last time more efficiently. So let me quickly first recap what we did. Uh, so So the link structure of the web graph basically is referring to all the hyperlinks that are there, which take one page, and if you click on the hyperlink, it takes you to another page. So if this was your web graph where you had a web page A.html and it had a hyperlink which took you to web page B, then that would correspond to the arrow that's shown right here from A to B. That arrow means that somewhere on web page A, you have a hyperlink, okay, which you can create using an HTML tag like /href equals and then the URL, and that hyperlink takes you to web page B. And together, if you take all the hyperlinks and you can put them together, you can form this directed graph, okay? And what we want to look at an algorithm which actually sorts all the web pages by their importance. And so the algorithm that we're going to be looking at is going to take as its input a graph like this, a directed graph. So you have web page A here pointing to web page D and so on. And so given all this information about which web pages point to which other web pages, our goal is to basically output a ranking of the web pages. And the output is a probability vector. That means each of the components is non-negative, okay? It's not negative. It's either 0 or positive, and the components sum to 1, okay? And this basically tells you that web page A, which has a higher score than web pages B, C, and D, would be given higher importance than the other web pages. So when you actually rank all the web pages, you would list web page A at the top of your search results. So the question is, how do we arrive at this probability vector that ranks the different web pages from this directed web graph? And that's what we've been looking at. Now keep in mind that this ranking of the web pages is only dependent on which web pages point to which other web pages. It does not actually depend on the query terms. Okay, of course, which words you enter in your search query is also extremely important. And there's another ranking called content-based ranking, which is also computed by the search engine. What we're looking at in this module is link-based ranking. And Google puts together the ranking obtained from various methods and combines them, probably using some machine learning technique, to arrive at a final single order in which to show all the web pages to the user. Okay, so the question is, how do we go from the link structure of the web graph to determining the importance of the various web pages? And last time we looked at an algorithm called the idealized PageRank algorithm, which took a web graph as its input and outputs a probability vector in the following manner. You first compute what are called the flow equations. So you say that the importance given to a web page depends on the importance of the web pages that point to it. The importance of web page D is determined by the fact that node A points to node B, and there are actually 3 outgoing links from A. So the score of web page A is distributed equally among all 3 out neighbors of A. And therefore, there's a score of RA/3 that's given to D. Similarly, there are 2 outlinks from B, and so web page D gets half of the importance of web page B. So when B points to D, B is basically endorsing D or supporting D or voting for D. And in fact, it's giving actually half of its importance to D, the other half to A. And that's how you get this equation that RD is RA over 3 plus RB over 2. So in general, the score of a web page is some linear combination of the scores of the web pages that point to it. And if A is very important, then automatically D becomes very important because RD depends on RA over 3, and that's how it should be. Okay, and then the sum of all the, of course, you can always scale your components RA, RB, RC, and RD and still get another solution. And in fact, 0 is a solution as well to the system of 4 equations and 4 unknowns. So we set up, and we want to have a probability vector that will make the solution unique. So we have an extra constraint that the sum of the components of the PageRank scores is equal to 1. And we know how to solve the system of equations. We can go ahead and get 4 equations and 4 unknowns and then solve it by inverting a matrix.